Dear students and other interested parties, in this video I want to show you another approach to the straight line equation in three-dimensional space. Imagine, you are here on the road right now. Your buddy calls you that his car broke down on the way to you. However, it could be at different points, all of which are on a straight stretch of road. How do you best get to him? This problem can be modeled mathematically with a straight line equation. What you need to know about straight lines is the following. What is a straight line? How is a straight line described? And how do you set up a straight line? A straight line can be described as follows: while a line runs in a straight line from a starting point to an end point, EA is limited by these 2 points, the straight line through these 2 points is infinitely long. And that both in 2-dimensional and 3-dimensional. The position of a straight line in the coordinate system is described by a starting point vector A and a direction vector V. I have now chosen A and V, but of course you can in principle also use all other letters. If you add any number of direction vectors to one another, you now get the straight line. Write this down as follows. The straight line G consists of all points x, which can be reached by first running down the starting point vector and then running any number of direction vectors from this point. I also made a video on this channel where I tried to reach points on a straight line by walking on a straight line in the coordinate system. It is important to understand that the direction vector can not only assume integer multiples, but any length. I can only indicate this here with the green vectors. It is therefore important to always add to a straight line equation that the parameter, in our case k, by which the direction vector is multiplied, comes from the real numbers. This means that the direction vector can have any length, and this ensures that our equation really contains every point on our straight line. This notation of a straight line is also called parametric representation. Back to our friend who broke down. In order to get to it as quickly as possible, it makes sense to first take the driveway to the main road and drive from there in the right direction for a long enough time. In order to set up the straight line equation for the road, we only need a suitable coordinate system. Now you just have to read the vectors in the coordinate system. If you have problems with this step, please write them in the comments. I also have a video for you on how to draw vectors in the coordinate system. And already we have the straight line equation. Now we can look for the 3 places where our friend can be. The point P is directly opposite the large tree. This means that in order to reach the point P we have to substitute the number 1 for k in the straight line equation. That means, we reach P by first driving along the starting point vector and then driving once the direction vector. To reach point Q, we have to travel 3 times the distance from the driveway. Hence we have to insert the value 3 for k in the equation. And to get to point R, we have to travel 1.5 times the distance to the tree, but in the opposite direction. This means that we reach the point R by inserting minus 1.5 for k into the straight line equation. In exams there are often the following tasks: determine the equation of the straight line that runs through points P and Q. In order to work on this task, it makes sense to first write down what is given and what is sought. The coordinates of the points P and Q are given, and the straight line equation that runs through these points is to be determined. Now let's make a little sketch. Here is our point P and Q is about here. This means that we use a point as a starting point and use it to determine the vector that shows us the direction of the straight line. So we get our starting point vector by calculating the vector from the origin to the point P. Oh yes, that's simply the position vector of P. And now the direction vector. This corresponds to the connection vector from P to Q, so we calculate top minus base point and get our direction vector of the straight line. It wasn't difficult at all. If we now insert our 2 vectors into our general equation, we see that the straight line is described by all points that lie k times away from our starting point vector along the direction vector. One could just as easily have used Q as a starting point vector. You can try that yourself as an exercise. Just pause the video, find the solution. I'll summarize everything you need to know to determine a straight line through 2 points with the help of vectors. I recommend you to write this down, so that you can remember it better. So, given 2 points where a straight line should run through, we find the equation by determining a position vector and a direction vector and inserting these 2 vectors into the general equation. The position vector is determined from any freely selectable point on the straight line, and the direction vector is calculated by determining the connection vector to the other point, from the starting point. You now only have to insert these 2 vectors into the general formula and we're done. If you want to draw this straight line and are no longer sure how to do it, then I have also video on this channel. Or you want to know how to determine the position of 2 straight lines or how to set up a plane, I also made a video for you. But now we have everything. If you have any suggestions for this video, I would be happy if you write them in the comments. These are my first steps as a teacher on YouTube, and I am aware that I still have a lot to learn and improve. Suggestions for other topics would also be interesting. A like and subscription to this channel would help me, because then my next videos will be listed higher. Have fun and see you soon.